Greetings, my name is King Sungkit, and let me and my group present to you the Child Nutrition Advisor Expert System. As an introduction, our system addresses pediatric nutrition for children aged from 1 to 12. Parents mainly struggle with understanding age-specific dietary needs, struggle to manage deficiencies like iron or calcium with their children. They cannot identify harmful ingredients effectively, and also they have limited access to nutritionists. Well, what are the consequences? It leads to obesity, malnutrition, diabetes, and developmental delays of children's of the parents. So our objective is firstly, we want to provide age appropriate recommendations for three main age groups of children. We would like to detect and address nutritional deficiencies. Thirdly, we want to implement safety and monitoring uh, alerts, automatic ones. And fourthly, we want to accommodate practical constraints like picky eaters and meal timing. Throughout our project, we collected knowledge from three main sources. Most of it is from expert interviews with Dr. Norizam Yusuf, a respectful lecturer in FDMK. And 50% is from his research on fuzzy logic for children's health, and the remaining is from WHO guidelines and BMI standards. And what we've gathered of our findings, we categorize into five types of facts: age related, nutritional, food characteristics, contextual, and safety facts like allergens.
Hi, my name is Nur Ayuni Akila, and I'm going to present about the methodology. So, process of the KBS development. Development followed seven steps, which are problem analysis, requirement specification, preliminary design using clips, knowledge acquisition with the expert, implementation of rules, validation and verification with test cases, and ongoing maintenance. Okay, next one about knowledge acquisition. For the knowledge acquisition, we use structured interviews, protocol analysis, and document review to extract both shallow and deep knowledge. Shallow knowledge like if then rules, meanwhile, deep knowledge is like about causal relationships. Okay, next methodology is about rule formation. Rule Rules formation are organized in five phases. The first one, classification rules for each group. Second one, safety filter rules to reject dangerous food. Third one, scoring and boosting rules to rank healthy options. The fourth one, preference and adaptation rules for picky eaters. And the final one is final processing rules to display result with reasoning. Okay, so we proceed with knowledge representation. As you can see, this is our tree or chaining graph. So this is the tree graph that's showing forward chaining flow. It's structured based on the rule formation phases, and you can pause and zoom for the details. As you can see, it flows from input through classification, safety filtering, scoring, adaptation, and to the final output.
Assalamualaikum. My name is Putri Farhat. So I will demo our system. So our system is Child Nutrition Advisor. The purpose of the system is to support parent or caregiver in making better food decision for child based on age, allergy, nutrition deficiency, eating behavior, and meal time. So the system began by different templates such as chart, food, and suggestion. So this template structure the knowledge by specify slot condition and allow value. When the system run, it collect user input fact including the child age, allergy, deficiency, picky eater status, and meal time. At the same time, the system asset expert knowledge in the form of food database facts such as vegetable, fruits, processed food, and junk food. So next, we go to decision making is performed using if then expert rule. This rule applies safety checks and nutritional logic. Variable and well-cut allow the rules to handle multiple food items dynamically without duplication. For example, a single rule can reject any food that too oily and unhealthy or unsuitable for picky eaters. Next, the system uses forward chains. A mini rule are fired automatically once failed are asset. So, salience value are applied to control the rule execution order. Ensure the edge classification happen first, followed by safety checks, scoring logic, and finally output generation. This guarantee a correct and logical reasoning flow. So we go to output. So this is the output. So first we enter China, Ali, age, and allergy is, for example, milk, and limit protein. Is the child a picky eater? We say, for example, yes, and enter meal time today. So the output begin with a nutrition report showing the recommend foods marked with OK and have a score. The score is calculated based on food type and rated it match the child nutrition deficiency. Higher score indicate healthier and more suitable for food choice. That the system show the reject foods along with clear reason, such as child is a picky and refuse vegetable. The system also generate suggestion. For example, make air fryer potato wedges or sweet potato fries with less oil. In conclusion, this demo show our system effectively apply templates, facts, if then rules, pattern matching, variable and forward chaining to produce accurate, explainable and useful decision. So that's all from our group.
My name is Tiong Jin, and now is our result and discussion. For example, to see the system in action, let's look at Sunny, a sexist or with an energy deficiency and a habit of being a picky eater. For her daytime meal, the system identified her as a young child and prioritized high energy density. Chocolate, for instance, scores 22 points, receiving a massive energy bonus, while fruits score a modest 10 because it's daytime. The system allows the sugars through it would automatically reject it at night. To handle her pickiness, our safety filter doesn't just suggest vegetables, it suggests hiding them between the meal. In one conclusion, we addressed her age-appropriate advice, her deficiency address, safety monitoring active, and practical constraint handle. So it's so that how the parents will know what to feed and what to avoid and how to adopt the food. It giving the parents a clear and actionable plan. This is the conclusion of our report. So start with our cost range. The system is built on expert level reasoning that provides highly personalized, age-specific advice. It's designed to be forgiving. It's handled incomplete data logically and specifically supports picky eaters by offering alternative. Most importantly, it doesn't just give an answer. It provides the reasoning and tips behind every recommendation. And of course, there are boundaries to the current version. We are currently input dependent, meaning the quality of advice relies on the accuracy of the user. Our scope is also static, limited to our predefined food database, and the system doesn't not yet learn or adapt to users over time. Therefore, to bridge those gaps, our roadmap focuses on three pillars. First, we are expanding the rules based on cover more complex scenarios. Second, we are moving from manual input to real-time data via variable integration. Finally, we are introducing adaptive learning, allowing the system to evolve based on direct user feedback. And that's all. Thank you so much.